Still page 7. This will be page 7 until we get to the next section. I know the microphone or the camera can only hear what I'm saying. It can't hear anybody else in the room.
Then how will you know if we ask you a question? How will you know what we ask you?
You will, it's like Jeopardy. You'll have to give the question based off of the answer I give you.
What is?
All right, so faults. There are 3 types of faults we're going to talk about today, and you're going to draw them. Part of your homework is having to draw them out and summarizing, so make sure you take good notes. The first one is related to one of the vocab words that we've talked about, which is a ridge. So find where the ridge is in your notes, and I want you to tell me what is a ridge. Chad, what is a ridge?
Where new landmass is made.
All right, a ridge is where new landmass is made. So at a ridge is where you're going to have a divergent fault. So if you don't know what a ridge is, make sure you write that down. So the first one is a divergent fault. Divergent fault. What does to diverge mean?
Move away.
To move away from one another. To diverge is go away. So at a ridge where new landmass is being made, what is happening to the plates on either side of that new landmass? They're moving away from one another, yes. So an easy drawing, which when you guys do your homework you have to do a more complicated one, is you have 2 landmasses moving away from one another. They diverge, they go away. So they move away from one another. All right. So let's draw a little bit more complicated one, and we're actually going to illustrate how this happens. So draw this on your paper as we go. So draw the big rectangular box.
Does it have to be really big?
No. I'm just making it really big so you can see it. All right, so this is a cross section of a plate. So think of it as like this, just a part of a plate. Well, underneath that you have the mantle. And the plates, remember what, if we look at the principles of plate tectonics, the crust or lithosphere is moving all the time on top of the mantle. So you have kind of the liquid portion underneath. So the crust is just made up of all these puzzle pieces, these plates that are constantly moving around. So at this spot we have magma coming up underneath the ground. So as that magma hits the plate, well, the plate is still intact. The plate's not separated. It's still together. It's intact. So this magma has a lot of force because the earth has a lot of force underneath, so it pushes up. So as it pushes with that force, it starts crumbling this plate, and it buckles and starts to break apart. And then the magma works its way through. And as it works its way through, what is it going to do to the surrounding crust? What is something that's really, really, really hot going to do to melt it? It's going to melt it. And as it's also coming up, what is it going to cause these plates to do? Kind of push apart. So it's going to cause the plates to push apart. You're getting a melting of a crust. Next thing you know, you almost get this thing that looks just like a volcano in the crust, yes. And you get, if you look at the ridge, the Mid-Atlantic ridge, it almost looks like there's like a scar. So the most famous of all the ridges is the Mid-Atlantic. So if we look at this map, the Mid-Atlantic is represented by the red line in the middle. Now if you want a closer look, it'll be in the back, but there's a ridge that goes all the way, starts way down here, comes all the way up. I'll actually draw the whole thing. Now notice that it is in the middle of the Atlantic, hence the name Mid-Atlantic Ridge. So it goes all the way up here. That means this is where all new ocean floor is being made continuously. So it comes up, it breaks apart, it cools because it hits the water. So this eventually will separate. So we will actually get further away from Africa and Europe on this side, but we'll get closer on these sides as they move further apart. Now, if we look, there's this little landmass up here where the Vikings stopped. Anybody remember what that was called? Iceland. So Iceland up here is right in the middle of the Mid-Atlantic Ridge. So their island there is right in the middle. So what's going to happen to their island?
Separate.
It's going to separate. But what's going to fill in the middle? New land. So it's actually not separating, it's getting bigger. So an example of a really famous divergent fault would be Iceland. It is on the Mid-Atlantic Ridge. I abbreviate it MAR, Mid-Atlantic Ridge. So when I write down MAR, that's what it means, Mid-Atlantic Ridge. So you have Iceland, which is on the Mid-Atlantic Ridge. So let's use a sidewalk for an example. Who has walked on a sidewalk before? So everybody raise your hand. We've all walked on a sidewalk. Who's tripped on a sidewalk before? Everybody raise your hand. We've all tripped on a sidewalk before, especially rollerblading. Oh my Lord. Anyway, think of this as a sidewalk briefly. Sidewalk is basically the same thing. Think of it when you have the crack, you have the crack in the sidewalk. Think of those as two plates. What happens when water seeps into the sidewalk and then turns into ice?
It will separate.
It expands, and the sidewalk will start to crack and break apart. Well, the same thing happens here. As this magma reaches the surface and gets cooled by seawater or air, it's going to cool. And then what's going to happen as it cools? It's going to expand and cause the floor to move apart even more. So that is basically a divergent fault. Are there any questions on what a divergent fault is? Where's the most famous one? Mid-Atlantic Ridge. What's on the Mid-Atlantic Ridge? Iceland. All right. Well, let's use our brains, which we've been graced with. We've all been graced with them. We just don't all use them. All right. So let's think. If we have one spot where the seafloor is splitting apart and the Earth is remaining in a shape, there has to be another spot where the seafloor is what? Colliding and shrinking. So what is it called to come together? What kind of fault would that be? We all converge. So convergent fault is the opposite of divergent fault. Divergent fault is where the seafloor is spreading. Convergent fault is where the seafloor is coming together. Or where two plates are coming together. Let me rephrase that. All right. So if we look at convergent, there are three types of convergent faults because there are in three ways that seafloor and continental crust can come together. So if I have two types of plates, I have continental and I have sea, what are three different ways these things can come together? Let me see if I have. Oh, I do. And I do not. The other blue one? All right. I am missing another blue one. No, I just don't know if I, well, here we go. We have another green. All right, it's a light green. So think of it as blue. Anyway, I have continental crust, I have seafloor crust. So I have multiple continental crusts, I have multiple seafloor crusts. What are two ways that, three ways that I can have interactions between these crusts? All right. I can have blue and green. What is that? This is seafloor. This is continental. So I can have oceanic continental crust. All right. So I could have the combination of an oceanic plate meeting a continental plate. They would hit each other. That would be one method. All right, what would be another one? Continental, continental. All right, good. Well, I'm hoping you guys can guess the last one. All right, oceanic, oceanic. All right. So, we can have oceanic crust hitting continental, or oceanic plate hitting a continental plate. We could have a continental plate hitting another continental plate, and we can have an oceanic plate hitting an oceanic plate. Those are the three types of convergent faults. But now let's draw a convergent fault and see what it actually looks like so we know what's going on here.
What's the difference between the two plates? Oceanic and continent.
What are we on?
Continent.
We're on a continent, so what kind of plate are we on?
Flat.
Are we on an oceanic plate?
Oh.
All right. That is a really good question, actually. What is the difference between an oceanic plate and a continental plate? An oceanic plate is one that is primarily underwater. A continental plate is a plate that's above water, yes. All right. Primarily above water. There are parts of a continental plate that will be underwater. If you go off to the coast of California, you can go out a little ways before you hit the end of the plate, because it gets really, really deep all of a sudden. And the water gets really blue. It's really pretty. All right, so what we have when we have a convergent fault, we have two plates coming together. So you have one plate on one side, and you have another plate that's coming in. As it comes in, one of the plates has to go somewhere. One of them is going to have to go down. It's just the way it is, because it has to go somewhere, so it's going to go down. It can either be this one or this one, but we always use the left side as the one that goes down. So generally, the plate that submerges or goes below the earth to be recycled is the one that is more dense, because when it's more dense, it is heavier, and heavier items sink. The one that stays afloat is the one that is generally lighter, or not lighter, but less dense, because it floats. And it's generally the one that's bigger, because obviously if you have two objects and you have one really big one, one really small one, the really small one's going to get squashed. So you have this other plate which comes in. So we have plate 1 and we have plate 2. So we'll call this plate 1, and we have plate 2. So plate 2, what can you tell me about plate 2?